Now, unfortunately, unlike some of our last examples where we were able just to look at the equation and conclude that there is some really simple form that we can apply to this, these two equations right here seem a bit more difficult. And so we have to learn one more principle, and our principle here is this. We are looking for a way to isolate our expression. So in this case, we want to isolate our exponential part of our expression. So in this case, I've got 6 times the quantity, 2 to the 3x minus 1, minus 7 is equal to 9. My goal, I want to somehow isolate this part of my equation. I want to isolate the exponential part of my expression. So I want to isolate 2 to the 3x minus 1, which means I have to do all of the algebra around it first. So that would mean to undo what's been done to 2 to the 3x minus 1, I'm going to have to add 7 to both sides. So I'll have 6 times the quantity 2 to the 3x minus 1 equals, let's see, adding 7 to the left side gives me 0, adding 7 to the right hand side gives me 16. Alright, but I'm still not isolated yet because I've got this multiplication of 6. So now I'm going to have to undo that by dividing both sides by 6. So if I divide both sides by 6, I get this equation, 2 to the quantity 3x minus 1, that's our exponent, is going to be equal to 16 divided by 6. Now, you should take a few moments right here. We've got to reduce this. 16 and 6, both divisible by 2, is really the same thing as saying 8/3. That's what we want. Always, 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 always simplify your fractions. Okay, so now we've got this equation, 2 to the 3x minus 1 is equal to 8/3. Now you might recognize, well, this is the kind of equation where we have to use our inverse logarithm property, right? We want to go to the property here that says, well, to get rid of that exponential form on the left, I have to take the logarithm base 2 of 2 to the x, or 2 to the whatever it is, to isolate that, right? So if that's what my property looks like right here, I'm going to take advantage of this. I'll make it a to the x so it's more familiar. All right, so what do I do here? Well, take the logarithm with a base 2 of the quantity 2 to the 3x minus 1 and set it equal to the logarithm base 2 of that quantity 8/3. Now, this property can be used over here on the left to reduce this so that the logarithm base 2 and the 2 as a base of our exponent goes away, and we're left with the exponent 3x minus 1 is equal to that logarithm base 2 of the quantity 8/3. Well, we can actually use a couple of properties right here to reduce this even further if we wanted to, but just for the moment, we want to isolate x. So to isolate x right here, what I'm going to do is I'm going to take this to be 3x is equal to 1 plus my logarithm on the right hand side, so logarithm base 2 of 8/3, whatever that turns out to be, and then dividing both sides by 3 gives me 1 plus this logarithm base 2 of 8/3 all divided by 3. Now, if I had to go through and I had to evaluate this quantity with a calculator, how would I rewrite it? Well, I would actually rewrite it this way. X would have to equal 1 plus, I could just take my natural log of 8/3, whatever that would be, divided by my natural log of 2, and then divide that whole quantity by 3. Or stating it one more time, even more simply than that, 1/3 is going to be multiplied by the quantity 1 plus, because of the division rule up here, I'm going to take the natural log of 8 minus the natural log of 3, and I'm going to divide that by the natural log of 2. And use this as my exact form solution. Okay, we'll do another one here in just a moment.